All right, this lesson, section 4.6, is on linear inequalities. So before we get started, we need to review how to graph a line. So let's review here. Number one, y equals negative 3/4 x minus 2. So the first thing you want to do is look for the y-intercept. Our y-intercept is negative 2, so go to negative 2 on the y-axis. Remember, this is our x down here, and this is our y, and the slope is negative 3/4. So we're going to go down 3, 1, 2, 3 over 4, 1, 2, 3, 4. You might want to do that one more time, and then it's a negative slope, so it should be going down from left to right, and it does. There you go. All right, the second one, before we can graph it, it's not in slope-intercept form, so we'll have to do an extra step, a couple steps where we want to solve for y. So we'll subtract 2x from each side and get 3y equals negative 2x plus 15. Divide by 3, everything by 3. So y equals 2/3 x plus 5, and that's a negative 2/3 x. So we go to 5 on the y-axis, 1, 2, 3, 4, 5. Go down 2 over 3, and there's our line. All right, so that's review from a couple sections before, slope-intercept form. All right, so you can grab a note sheet to follow along if you'd like, or take your own notes. All right, so here's our goal today. Section 4.6 is on graphing linear inequalities, and our I can statement is I can graph a linear inequality and determine if a point is a solution to the inequality. All right, so first of all, to graph an inequality, you need to graph the boundary line. So instead of y is less than, it's y equals 2x plus 1. So we're going to graph that boundary line. So we're going to go to 1, it's our y-intercept, do a slope of 2. Okay, so it's going to look like that. But the next thing is we have to make the boundary line either dotted or solid, based on if the inequality is just greater than or less than, or if it's less than or equal to or greater than or equal to. You might need to make a note here. I know students do tend to forget this. This is your less than, this is greater than. All right, so up here this is less than. So we're going to make a dotted line. Okay. And then we need to determine which side of the line to shade. Okay, I'm either going to shade above or below the line. Now, I like to make everything sound simple in math. This is less than. So if you think of the y-axis and being less than, this is your y-axis here. Less than is below. So you would shade below. Ideally, what mathematicians want you to do is take a point on the graph, anywhere. I like to pick this point here, 0, 0. As you see from what I shaded, that should be a solution. Well, let's check and see. If the point 0, 0 is a solution, it means every point, and that's what the shaded area means, every point in the shaded area is a solution. Well, let's see if this does work. That's my x, this is my y. Is 0 less than, now 2 times 0 is 0, plus 1. So is 0 less than, that's just going to be 0, 1. Yes, it is. So that is a solution. We showed both graphically and algebraically that that does make it true. All right, so solving an inequality by graphing isn't much different than graphing the equation, other than you have to shade then one side or the other and determine which side to shade. So let's try this one. Y is greater than or equal to negative 2/3 x plus 4. Again, we want to graph the boundary line. So that's going to be y equals negative 2/3 x plus 4. And decide if it's solid or dotted. Now in this case, because it's or equal to, it's going to be solid. So let's go to 4. 1, 2, 3, 4 on the y-axis. And we're going to go down 2 over 3. and it's a solid line. And then we just need to determine, do we shade above or below? This is greater than, so we're going to shade above. So that means any point over here, any point in this area is a solution. So the point 1, 2, 3, 4, 5, 6. So 5, 6 is a solution along with an infinite number of other points. So we can fill this and determine which side of the line to shade. And there you go. All right, let's look at this one. Now what's wrong here is, well, there's nothing wrong, but what's a little bit different here is it's not in slope-intercept form. So we're going to have to take some extra time and just move this x over. We'll get 2y is less than or equal to negative x plus 8. Divide by 2. So y is less than or equal to negative 1/2 x plus 4. Remember, you solve an inequality just like you solve an equation. The only thing that you might need to do is if you ever have to divide by a negative here, you'd have to change the direction of the inequality. But we didn't have to in this case. So let's go to 4, down 1 over 2, solid line, because it's or equal to. I'm right here, solid line, and it's less than, shade below. Determine if a point is a solution. I'm going to try 0, 0 again. That is in the solution area. So 0, 0 is a solution. We can check. I can just put it back into here if I want. This would be 0 is 0 plus 2 times 0 is 0 plus 0. Is that less than or equal to 8? Yeah, 0 is less than or equal to 8. So 0, 0 is a solution. All right, so in order to complete the quiz on Apex in section 4.6, linear inequalities, can you graph a linear inequality and determine if a point is a solution? If you feel pretty comfortable with this video, go ahead and take the quiz on section 4.6. If you need some more help, come and see me and I can work through a few problems and answer some questions. Thank you.